So I've been coming to Taiwan for over 30 years. I've been in the semiconductor for more than 4 decades. And I would say that for me, I've never, ever been more excited. I still feel like the very first day that I started in the industry. So let me ask a question. How many people have been in the industry more than 30 years? Stand up, all the people, more than 30 years. Some people. Now, round of applause. How many people are in the semiconductor industry today? Stand up. Everybody, stand up. So, what I would say is that what we do together is like magic. It's really, I'll talk about that here today. But, I think that over and over again, what we do is we make the almost impossible possible. And we also make what we currently think is impossible possible. That's what we do in this industry. And there is no industry like this anywhere on Earth. The velocity of innovation, the magnitude of the innovation, it's just, I'd say it's not for everybody. This is a very fast-paced industry, but if you love challenges, if you love shaping the future, there's no place better. And the other thing that I realized over the last few years, and the whole world has realized, is actually we're all very cool. We are cool. Many of us have been driving innovations for decades, and we knew what we were doing was cool. We knew that we were really creating magic together in this industry. But now, over the last 5 years, really the whole world is recognizing how important semiconductors are to the world as the foundation of the biggest global innovations on the planet. So, what I tell all the employees at Applied Materials, and what I'd recommend to you, is go home and tell your families all of those electronics innovations that are around us every day with semiconductors, that magic comes from all of us, and we're all cool. So anyway, that was my revelation here over the last few years. So if you look at the magic, this is an example of a smartphone processor with 16 billion transistors and 100 kilometers of wiring. And creating this chip that's the size of your fingernail takes close to 2,000 different process steps. But when you think about it, 100 kilometers, it's like going from the airport to Hsinchu and back. One person referred to this as sucking a smoothie through a straw, 100 kilometers long, with no resistance. Again, what we create is truly magical and truly amazing. It's just, and I've never, as I said, been more excited or optimistic about the future. So, the biggest tectonic shifts in technology, the biggest global inflections in the world, AI is the biggest of them all, $10 trillion by 2030. And certainly within Applied Materials, we're using AI in innovation, in product development, in operations and supply chain, in our field operations, in our infrastructure within the company. And this is the biggest inflection of our lifetimes. And IoT, robotics, industrial automation, autonomous vehicles, and renewable energy. All of these inflections that will shape the future of every country and every individual. At the foundation are semiconductor technologies and semiconductor innovations. So, The biggest focus in the industry today, and as I meet R&D leaders or ecosystem partners in the semiconductor industry, the biggest focus by far is energy efficient computing. That is the overarching focus for everyone in terms of technology roadmaps. So if you look at ChatGPT, going from ChatGPT 2 to ChatGPT 4, you can see that you're consuming 250 times the energy with one training of a model. And we'll hear from Microsoft, we'll hear from Google, we'll hear from others later today. But, and I know YJV, I think, is part of a panel discussion later in this event. But this focus on energy efficient computing is really key for all of us. And there is a race for AI leadership. That's the biggest race of our lifetimes. And it's really a race for energy efficient computing leadership. And you know, this 250 times increase in energy consumption is the same as 5,000 homes the power consumed in 1 year. So this is really the race that everyone is running. And then if you look at what have we accomplished, and again, I think we're all cool. What we do is we create magic together. If you look at what we've accomplished over the last 2 decades, you can see from TSMC a 10,000 times in energy efficient computing, which is truly amazing. That 100 kilometers of wiring, that's hard to imagine how you can create something like that, move the data lightning fast with almost no resistance and power consumption. And then going forward, we need to drive another 10,000 times in energy efficient computing over the next 15 years. And you see also quotes here from AMD. But I would say within Applied Materials, we're working with the ecosystem 10 years out into the future, 4 technology nodes out in the future. And, you know, again, I've been able to see in my time in this industry that we do make the nearly impossible possible. And I am very optimistic that we will, together, continue to drive incredible innovations to achieve these objectives. So, energy efficient computing, especially for AI, really 4 key technologies, and you'll hear from other speakers today about some of these technologies. But leading edge logic, you have a GPU with 100 billion transistors today, and you know that's going up at a very fast pace. High performance DRAM and compute memory is very important. High bandwidth memory and advanced packaging and heterogeneous integration, which is going to be an enormous inflection. The architectures that are there today will look very different in a few years based on these technology races that are happening through the industry and through the ecosystem. So talking to ecosystem partners, they all are focused on more energy efficient computing. So what happens in this industry is that we're always in a constant race. 10,000 times in 20 years, another 10,000 times in 15 years. You have all of these key technology elements that come together for computing, and in every one of these, there is a race. And if you look at what happens in this industry, whoever is first to market in any one of these segments wins big, and everyone else is left behind. That's just really the way it works. And so that means, again, the high velocity innovation is fundamental for every part of the semiconductor industry. And for Applied Materials, we're the leader in materials innovation for all of these different key enablers for AI, for the inflections that are coming, the architecture, device architecture races. We're positioned to capture over 50% of that inflection-based spending for all of these key races. And you know, the way, after many decades in this industry, what I'm most excited about is that we continue together to innovate in new ways. Because doing what we've been doing in the past is not going to get us where we need to go for the future. But these are the 4 key technology enablers. So if you look at the transistor roadmap, and again, every one of these device architecture inflections is a race. And every one of these inflections deliver improvements in energy efficient computing. So everyone is focused on gate-all-around, or the next version of gate-all-around, and in the future, CFET technology. So, and whoever gets there first with these types of technologies in high-performance logic becomes the leader, and again, everyone else is left behind. Of course, there are other innovations in high-performance logic, like backside power, but these are the races that are happening constantly in the semiconductor industry. And in memory, I know you'll hear some speakers here later from memory companies. It's the same thing. Constant races for these architecture inflections. The next big one that's coming is 4F squared. Some people call vertical gate, a vertical channel transistor. Again, it's a major change in architecture. And then after that is 3D DRAM. And all of these innovations deliver improvements in energy efficient computing. And as an industry, to achieve those goals, we have to bring them all together. There is no one thing that delivers the energy efficient computing that the world needs. It's all of these innovations and all of these technologies coming together. And what I would say also for all of these innovations, what you see is that there are material device architecture inflections that are the foundation of every one of these races. And if you love material science, like I do, this is so much fun, running these races, working together with our customers, working together with the ecosystem. And then if you take one of these parts of the device architecture, one of these parts of the chip, and blow it out, at the atomic level, it's truly amazing. And this is actually a simplified version of what this structure looks like. But you're really working with more than 25 materials, combined in more than 100 different ways. The interface engineering, as we're building these new structures, sometimes you're dealing with 2 atoms. And it is truly magic what we do together as an industry. So, I said earlier, where we need to go, we need to continue to innovate the way we innovate. And one thing I love at Applied Materials is that we have a very broad portfolio of technologies and competencies and a lot of innovation. Through my career with 3 different semiconductor equipment companies, what I've seen in delivering many innovations is a lot of innovation comes from combining technologies in new ways. And that's part of what we're doing, because the complexity, all of you that are working in the semiconductor industry know this, the complexity is increasing at an extremely high rate. So, making the impossible possible, or nearly impossible possible, you really have to think of new approaches to keep driving this energy-efficient computing roadmap going forward for the future. And I would say one thing that is now more important than ever, it's always been important, and the leaders today in the semiconductor industry are the companies that are great at this, which is high-velocity co-innovation. So, working together with partners with a high level of trust, because no one can solve these issues by themselves. No one can create these magic innovations by themselves. So, within Applied, that's when I tell the team, the number one priority is high velocity, number two priority is high velocity, and number three priority is high velocity. So, this high velocity co-innovation, and really innovating the way we innovate. I'll talk a little bit more about that later. But that's what we need to do, continue to do, and that's what we've done in this industry over the last few decades. So this is showing a part of the chip flow. And if you look at a 2-nanometer chip, there's over 2,000 steps inside that flow. So you're building all of these materials, all of these structures, shaping the structures, modifying the structures. Again, it's really like magic, how we do this. And then if you look at this co-optimization or integrated technologies under vacuum, this is where I've said that we're innovating in new ways. So by combining some of these technologies together, that's how we're able to deliver a 100-kilometer wire that can move data lightning fast with almost no resistance and low power. That wire is created with the tool, one of the parts of the process, 7 technologies combined under vacuum. And you can see here in this gate contact, part of this flow where you're combining different technologies together under vacuum, because when you go to atmosphere, you're damaging these interfaces, you're oxidizing the interfaces. So again, that's something that we keep doing. We keep inventing new materials. We keep inventing new ways to connect these technologies together. And certainly a key here, where we're delivering 50% improvement in contact resistance, is co-innovation into the device flow with our customers. So let me talk about innovating the way we innovate. So many of us in the semiconductor industry know creating this magic is incredibly fun, but also very, very difficult, and it takes a lot of time. Going all the way from concept to commercialization, and all of those different steps in between. So what we've been focused on within Applied Materials is innovating the way we innovate, and really working in parallel versus a serial type of process to innovate in new ways at higher velocity. So this is really what we're doing. We've announced a new equipment and process innovation and commercialization platform within Applied Materials, and we'll have customers, we'll have ecosystem partners as part of this innovation platform. And when we're driving all of these materials innovations that are within the chip, high velocity experimentation and how fast you learn is life and death in winning these races. It's all about being first to market for those device architecture inflections. So there's a great opportunity to rethink this serial process, to co-innovate together in new ways. And I would say that, again, all of us are looking for ways to accelerate innovation, especially for energy-efficient computing. So, let me summarize. As I said before, I've never had more fun in any time in my life than today. We're in such a fortunate position as an industry. The key global inflections that will shape the future is built on new computing innovations and semiconductors. It's just amazing. When we think about making possible a better future, again, all of us together, all of us working together, we're going to deliver innovations that will touch every person on the planet. And it will determine the competitiveness of every country and every individual. I know for my children, I have 15-year-old twins that are just starting into high school, and one of the things I've talked to them about, certainly following your passion, do something you love, be great at whatever you're going to do for the future, but I also want them to be AI experts. Because again, I think AI is going to transform everything that we do in this world. So again, these tectonic shifts, we're at the foundation. Energy efficient computing. When I'm talking to every customer and partner in this ecosystem, everything is focused on energy efficient computing. That is the overarching focus and goal for everyone in this industry. And as I said before, we cannot do this, any of us, by ourselves. The magic that we create together is truly amazing. So I'm personally looking forward to working together with all of you to continue to deliver the magic innovations that shape our future. Thank you very much.
Thank you very much to Mr. Dickerson. Thank you.